Like now?
Yeah.
Ah, good. Well, see, thank you for letting me know. All right. Hi. Today, well, we're just going to go over some things that I need you to know before we even get started here. One of them is just very, very basic conversions. The joke I tell, it's like going through the Inquisition. You got to know how to convert. So, just basic unit conversions. The one that you just, gosh, metric system. The standard metric conversions. I don't know why students have a hard time with these. But you've been told them or taught them ever since elementary school. I don't know why students still wrestle with them, but the prefixes associated with the metric system that I want you to know from big to little. The M is a capital M, which means it's a big letter, which means it's a big number. And it stands for mega, which means you're going to multiply something by 10 to the 6. You were right there. You were right there. I'm done. 10 to the 6, but mega million. Then we go in units of 3. K is kilo, which means you multiply something by 10 to the third. Without any unit, then there's nothing. We, again, typically go in multiples of 3. The one exception to that is centi, just because they're convenient to use in classroom rulers and stuff. But when you get to engineering school, they'll never use centimeters. Everything will be millimeters or meters. But if you see a lowercase c, then what that could be is a centi, which means it's times 10 to the negative 2. But again, that's kind of an exception. We will typically use milli, which means times 10 to the negative
3.
And some of mu. Know what that symbol is? It's the Greek letter mu. And it stands for micro. And that's, if we're going again in multiples of 3, that means this is times 10 to the negative 6. And then nano. And nano negative 9. Okay? Please have these essentially memorized. I mean, my gosh, you've seen them ever since I don't know when. All right? Now, elementary school teachers taught you to write this phrase about Kahn's hot dogs or something. I don't know. Please don't write that. That's very juvenile. What I would like you to do is remember exponents and just keep them like a number line. That's all I want you to do is remember these are just a number line, and how to convert from these from one to the other. So as an example, I mean, let's just pretend in our headsies between Turpin High School and Anderson High School, I don't know, what if it's 11.3 kilometers? I just made that up, I have no idea. Sounds-ish, right? But if it's that far in kilometers, then a very typical unit conversion is, okay, how many millimeters is that? I don't know, something along those lines. But something like that, you need to know just how to do in your head without, I mean, this should take very little thought. The way I explain it to students is, again, use these exponents as a number line. And so I'm going to just literally write them from negative 9 to 6 to 3 to 2 to 3 to 6. So if we're on a number line and we're going from negative 9, negative 6, negative 3, 0, and I guess the negative 2 I didn't write, but it doesn't matter. 3 and 6 is about the highest one we go. But all right. So if we're at kilometers, that's an exponent of positive 3. So let's pretend in our headsies we're just hanging out at an exponent of positive 3. That's u. And if I don't know, what did I say? How many millimeters is that? W, that's a big letter. Many millimeters. is there between Turpin and Anderson High School if it's that many kilometers. So what you are going to do is go from an exponent of positive 3 to an exponent of negative 3, and you're literally just going to pretend you're walking along a number line, and that's where you will end up. Okay? So U initial, U final. But anyway, you start at positive 3, you go to negative 3. So the number of decimal places you move is 6. You move 6 spots. So all you got to do is slide the decimal point 6 spots. Just start with the exact same number, 11.3. You don't have to change anything. 11.3. And I'll write these is exactly the same thing as 11.3. So they didn't change the number at all. Who cares? Just write the exact same number. The only thing is you will now multiply it by 10 to the 6. And the only decision we'll need to make is this going to be a positive exponent or a negative exponent? Meaning, do we need a lot of millimeters to make this a big number, or not a lot of millimeters to make it a small number? And since millimeters, you know, are about yay, kilometers are about yay, we need a lot of millimeters to get us to a kilometer, so that exponent is positive. Are you sure? Positive. All right. So that kind of skill, and again, it doesn't matter if it's not 1.13 times 10 to the whatever. It doesn't have to be in scientific notation. In fact, if it's not a big deal, because I don't know, the only people who care about scientific notation are junior high science teachers. Leave it as 11.3 times 10 to the 6th millimeters. And in fact, I usually don't write times 10 to the because I'm lazy. I write 11.3 E 6 millimeters. That E stands for times 10 to the. Okay? But something like that, I need you to remember. Exponential difference. Treat these exponents just like a number line. All you're doing is walking from one spot to another. All right? So basic metric conversion should be pretty simple. Other conversions might be standard units. How to go back and forth in between miles per hour, meters per second, feet per second, whatever. So just as another example, let's say you're going 55 miles for every 1 hour. So you're driving on a highway, whatever, 55 miles an hour. A very typical type conversion is how many meters per second would that be? All right? When you build these conversions, again, it's just like your chemistry teacher taught you. You will kill letters that are upstairs by putting those letters downstairs, and kill letters that are downstairs by putting letters upstairs. So if I want to kill these miles and turn them into, say, a meter per second, then since miles is upstairs, I need to kill them by putting miles downstairs. And from there, I can go straight into meters. That would be a conversion that would be given on a sheet, or you could look it up. It's pretty easy. And so miles are dead. We're in meters per hour right now. So if I want to kill the hours, I need to put those up there. When students first get started, they'll probably go from hours into minutes and then do another conversion, minutes into seconds. But I think, it doesn't matter. I'll do minutes here, and then that kills the hours. And I'm in meters per minute, which means there's one more conversion I have to do if I want to kill the mins. I got to put the mins up there and go straight into seconds down there. So another thing you'll notice is I didn't put any numbers anywhere. I did all the math with letters first, and that's something that I want you guys to remember to do all year. Do math with letters, not numbers, letters. Then once you see the units are what you want, now you can throw numbers in place. And most students know, okay, there's 60 seconds in 1 minute. You know there's 60 minutes in 1 hour. And then what you might not know is the number of miles to meters. 1 mile, if you remember from running in gym class, maybe it takes 4 laps around a track to get you to a mile, which is 1,600. And that's what I usually use. Some books will tell you 1610, 1609. It just depends on how specific you want to get. 1600 is what I usually use, but you'll probably see it written as 1610 in some books or 1609 in others, but it's not a big deal. That isn't going to make too big of a difference, okay? Now, when you do the math, please remember, do the math all at once. Your calculator's a stud, it can handle it. What that means is only type once. I don't like it when students baby step through the math. Every time you push a button, you have the opportunity to push the incorrect button. So, what I recommend students do is the math all at once. The way you do it is open a parenthesis, multiply all of the numerators together. So, your English teacher would say it as take the product of all the numerators. So 55 times 16, 10. There's the product of all the numerators. Close the parenthesis to tell the calculator you're done with the numerator. Then push the divide button and open a second parenthesis, so you're going to tell the calculator what you want it to divide by. 1 times 1 isn't that big a deal. It would be 60 times 60. Then close the parenthesis and push the enter button. So it's the product of all numerators divided by the product of all denominators. That's all it's doing. And when you do that there, boom, open a parenthesis, 55 times 16, 10, close that one, divided by 60 times 60, which you know is 3,600 anyway. It's about 24.6-ish. And that's meters per second. And this is the unit we'll typically use for speeds in a physics class. But just to give you an idea, 55 miles an hour-ish, 24 meters per second. But that type of conversion, again, is very similar. Heck, it's the exact same stuff that your chemistry teacher taught you in terms of like grams to moles and moles to atoms, that sort of happy chemeries. Okay? One other thing to just remind you of, what if you're doing area conversions, and let's say, I don't know, you're flying a crop duster airplane, and that airplane can cover, I don't know, I'm going to make up a number here. What if it's, it can cover, gosh, I don't know, 253 square meters per, that seems low, but I don't know, per hour. And since maybe most of us aren't very familiar with square meters, maybe we'll go into square feet per second or something along those lines, just to give you a conversion. Then how many square feet per second can that particular crop duster cover in? What I want you to then realize is I'm squaring these numerators, which means when I do these conversions up here, I'm going to need to square some stuff. So if you know, you're flying a crop duster plane, it covers this much area per hour. They want to know how many feet, square feet per second is that. You'll do the exact same thing. Start with the number that you know. So I'll take 253, and that'll be square meters for every 1 HR. And then you can just start killing letters. This square meter would go here as an M. And then if we want to go into feet, we can go to FT there. If I do the same thing here that I did up there, then every time I have a mile, I killed the mile. Every time I have a meter, I killed the meter. If I do the math now, all I did is kill the square of that meter. I didn't kill that meter, so this isn't a sufficient conversion. You got options. I don't know what options are either, but some of you still have them. You could write the exact same conversion again and go meters into feet, because now this M will kill the other M that remains. And in the numerator, you have a foot times a foot. That's a square foot. Or if you're like me and you're lazy, you don't want to write the same fraction twice, you can put it in parentheses and square everything. And then that square feet, square meter, applies to everything inside those parentheses, and that's usually the way I write it, but if you would rather not do that, you can write both fractions together. So now the meter squared dies, I'm in square feet now. If I want to kill the hours, I have to put those upstairs in what I say seconds, and instead of going from hours into minutes, I'm going to go straight into seconds. Again, because I'm lazy, because it's just 60 times 60, which is 3,600 seconds is 1 hour. All right. Meter, you may not know this offhand. It's like 3.28 feet. That's a number you'll always have access to. Those types of conversions are things that we give you. So then, all right. I think this is happy. The hours cancel. I'm in feet squared, so square feet per second. I'm ready to do the exact same thing I did up here. I'm going to open a parenthesis, and I'm going to multiply 253 times 3.28, 3.28 squared. And I'm going to close those, and I'm going to divide by, I guess I don't need a parenthesis, just 3,600. Divide by 3,600. And we end up with about 3/4-ish, 0.756, 0.76-ish, doesn't matter how many digits you write. In this particular example, 756 is how many numbers you have there. So, okay, 0.756, that's square feet per second. All right, and so those conversions. But this type of skill is something that, gosh, we do it almost daily, and I do it without even thinking about it. So hopefully you'll get good enough at it to do these sorts of things, and you may not even have to write out all these steps. But when we first start, please build all of the fractions, put the units in first, then fill numbers in, and do the math all at once. And remember, when you got to convoit, you got to convoit. Yay, physics.